Okay. I'll keep it like this.
Cool. This is a real test of like what remote's really like, where everybody's remote.
It's really a shame they gave us such a small room.
I know, right? When I saw the room, I thought, oof. I told them I'm going to make everybody move up. All you back row people need to move up so I can see you. I mean, you might as well, right? Except for Peter. Peter won't do it. Do we have note takers?
No, and we would love if somebody wants to help. Otherwise, I'm going to do it.
See, this is the problem with making me a delegate is I turn into a chair as soon as I sit here. And I think, oh, wait, where are my note takers?
If you could bully someone into taking notes who's in the room, Deb, that'd be highly appreciated. By making violent eye contact.
Yeah. So we won't start until somebody takes notes, though, I will say that. Can you? You're the best. Can we have more than one? Because then it's easier, right? Just big things, right? Because it's recorded and everything, right? So just,
Yeah.
you know, you don't have to transcribe it. We have that too, right?
So Deb, who is taking notes? We couldn't see that online.
MT. So Martin Thompson.
MT, perfect.
And then
Thanks,
hopefully
Martin.
some of these other people will pitch in. Because we now have like 10 people.
We're proliferating.
11, 12, maybe 13.
Should we get started?
Yeah.
Welcome all to KEYTRANS at IETF 123. We are your chairs, Siobhan and Prachi joining remotely, and Deb is very kindly being our in-person delegate. Thank you, Deb. This is the note well. It governs, or it talks about the IETF policies in effect, such as patents or code of conduct. Please do note this well, especially note well the RFCs we have around guidelines for conduct and anti-harassment procedures. Chairs are responsible for this to make sure you have a good and productive work time at IETF, but we also have the ombuds team. So please do get in touch if you need to raise concerns about harassment and unwelcome behavior. All right, agenda. We have a minute taker. Thank you, Martin. And for the agenda, we changed the order of presentations a little bit. Marie will be going first. And yeah, that's the only change to the agenda. Does anyone have any other requests for change to the agenda? If not, then let's get started. Just one thing, please remember to use the Meet Echo tool even if you're on site, especially for queuing, because that keeps things fair for both people in the room and people online. So please do use the Meet Echo on-site tool, even if you're in person. All right, Marie, are you around?
So do you want to do your own slides? Do you have slides? You can. Siobhan, do you want me to?
Yeah.
You load slides and I'll pass her the clicker. Yeah, see this little the clicker? Oh, that's all right. That's okay. We'll still give you the clicker. It's fun.
Sorry, not share screen, share slides.
No, share slides. There you go. You got it? Okay, ready? So you see the clicker sitting there?
All right. Hey, everyone. My name is Mari. I'm a product manager at Cloudflare. I work on privacy and emerging cryptography, and going to talk a little bit about our implementations in the current state of where they're at with the drafts. All right, so we have an early version of the draft that's been implemented. It's based on work we did last year on a non-draft compliant implementation of an auditor for key transparency that we worked on interoping with WhatsApp. This one, this kind of newer implementation is compatible with the architecture draft 0, which is an earlier draft, and the protocol draft 2. We also want to note that there are now 2 parties that implement auditors. There's one implementation in Java by Signal, and ours that is in TypeScript. So what we would like to see moving forward is an implementation for the whole specification across an entire language. So if we could see, a KT implementation and an auditor implementation in the same language, we think that that would make interop testing a lot easier. We'd also like to acknowledge and are very grateful for Felix from ETH Zurich for doing some formal analysis for the client. I saw in the agenda that Felix is talking next, so that's great. What else we would like to see? Test vectors to help facilitate implementation and interop, and a clear definition of auditor data structures. So right now we have to run our auditor through Protobuf or gRPC proxy. It would be nice to know or kind of standardize that so that we can extend our auditor to audit other KT implementations in the future. Right, that's all. Good? Yeah.
Yeah, hi. Thanks for the quick presentation and update. So just to get you correctly, you implemented auditing and auditing only?
Yes.
And what does it mean for 2 auditors to interop?
So to interop means to, like according to the draft 0, which is to make sure that the tree head is consistent and append only in nature, and to be able to check that against a KT implementation.
Yeah, I was more wondering about the interoperability of auditors because if I recall everything correctly, and sometimes details escape me, the auditor will interact with the transparency log primarily, right? So auditors won't interact with each other. And without it seems to be, I don't understand the claim without an log implementation. What does it mean for 2 auditors to be interoperable?
Oh, sorry, we're not talking about 2 auditors to be interoperable, just for the auditor to be able to audit the key transparency implementation.
Okay, cool, thanks.
Cool. Thanks.
Just a reminder, or sorry, Maria, I had a few questions.
Oh, is he in the queue?
No,
okay.
I'm using chair privilege, but I can add myself to the queue.
Go ahead.
So thank you so much for this presentation and bringing, to the IETF work that's happening in real life. So just wondering, if you're in touch with Signal folks, it seems like from their code base, they're making some changes to the protocol document. Could we bring those changes to the IETF and see if there's something that we need to change in the protocol document? I guess that's my first question. If you're aware of stuff that you had to change at Cloudflare or Signal had to change, because it does look like there were some changes.
I haven't looked in detail at the changes that Signal has made, but I'm happy to encourage them to bring those to the IETF if that's helpful.
That'd be awesome. And then, is Cloudflare's implementation open source? I saw the link to Signal's, but not to Cloudflare's.
No, it's not open source. We're definitely considering making it open source though.
Last question: is there also a client implementation in the works? Do you know, or if you can talk about that?
We're not working on a client implementation, and I'm actually, I don't know if I should comment or, make any claims as to Signal.
Thanks. I think Brendan's on the queue.
Hey, I just wanted to say that it is actually the kind of other way around. It's not that Signal took the IETF draft and then made changes to it. It's that Signal adopted a very early version of the key transparency draft, and then a bunch of changes have happened to the draft in the meantime since they've implemented that in response to difficulties that we had with their implementation. But also the Signal key transparency server is open source now as well. So you can see it on their GitHub. They have the server open source. And so interop, I guess, means that both of those auditors can both audit the same KT server. Yeah.
Cool.
Thanks,
for
Brendan.
clarifying.
Yeah, I mean, this is super encouraging work or news for the working group that stuff is being deployed and being changed in the world. Right. Thanks, Mari.
Okay. Thanks, folks.
I think next up we have we have Brendan. So let me share the slides, and then let me pass you control.
All right. Hello, everyone. So what I'm going to present is, first of all, changes to the architecture document. So the first sort of change to the document that we've done is originally we had text in the document saying that users are considered to own a label if they initiate all changes to the label's value. And so what that means is that essentially we were saying that every time a label's value changes, it was because the user went in and themselves did an update operation. And that ended up being a little bit too strict in practice because in a lot of applications, KT is not actually the authoritative source for a user's public key. I believe the way the WhatsApp implementation works is that KT is kind of this eventually consistent thing in the background, and then users will go and sort of verify against KT, but sometimes it's out of date. And so you just show like a little soft error saying, couldn't verify right now, please check back later. So you have this kind of use case where the service operator is making changes to KT in the background that is unrelated to the user. And what's actually happening is that the user is just being informed after the fact of the changes that happened, and the user is verifying that those changes are acceptable to them. So the text was changed to users are considered to own a label if they either initiate all changes to the label's value through that synchronous request response process with the server, or if they have to be informed of changes to the label's value, to sort of capture that idea that the user is responsible for the label's value, but they don't actually make the changes to it. And of course, that also is nice because it covers use cases where you maybe have multiple users or multiple devices that are changing the same label. So one of them can make a change and then the other ones can all pick it up. Okay, and then the other kind of big thing is we talked a bit at last IETF about changes to contact monitoring. The way that it used to work was that we required users to interleave requests with each other. So what would happen would be that Alice would look up Bob's public key. Bob would have to come online later and check that his public key is represented correctly in the log. And then Alice would have to come online again after that and check that what Bob checked was correct was what she saw. And so the whole sort of flow was actually not secure if that interleave of requests didn't happen correctly. The change that we made was that we added timestamps to the leaves of the log tree. And the effect of that was that users could then kind of simulate this idea of interleaving their requests, or they could look at different points in the log that were created at different points in time. But in terms of actual wall clock time, the users can come online whenever they want. So in this section, you can see that Alice looks up Bob's public key. She waits a little bit. She does her monitoring that she has to do. And then Bob can come online whenever he wants to and do his own monitoring. The contact monitoring section of the architecture draft was updated to make it more clear that that's what was happening, or that was updated to make it more clear that this can work that way, which is nice because it's a lot more like user friendly. And then we also changed third-party auditing a little bit. So the protocol and the architecture document are pretty strict that once the transparency log is set up and once it's configured, that the configuration can never change, because that introduces a lot of really difficult security issues that we don't really want to deal with. But specifically in the case of third-party auditing, that was also a little bit too strict, because in like pop culture, the way that people think about transparency logs is that the transparency log can live for a very long time, and then third-party auditors can kind of come and go. Third-party auditors are not really ephemeral, but they have the option to leave if they don't want to do this anymore, and then new ones can kind of come up over time. And that can introduce problems if, number one, the log is very big. If we require the auditor to start at 0, that might be a prohibitively large amount of stuff that the auditor has to go through. And of course, the document also supports pruning, so requiring the auditors to start at 0 might not be possible if 0 has been deleted in the time that the log has been alive. So the document was updated to add the sentence saying, given that transparency logs are supposed to live for a very long time and that third-party auditing arrangements can change over time, KT allows auditors to start auditing a log at any arbitrary point. And then in the protocol document, we essentially put the point at which an auditor started auditing a transparency log in that configuration. So it's in the configuration with like the auditor's public key and stuff. And then we added some points in the protocol document where if users are relying on a security guarantee from a third-party auditor, they check that the auditor has been auditing the log long enough that they actually get the security property that they want. So yeah, and that verifies that users actually get the security properties they want from the auditor, even if it hasn't been around, forever. Okay, and then sort of the architecture document from the top, sort of everything that's in it, we define 3 interactive user operations that are like request response operations that we do with the server. The first one is search, which allows you to either search for the value of a specific version of a label or search for the greatest version of the label that exists. We also have this update operation, which lets users change the value of a label, or by change the value, I mean they insert a new version of a label with a new value. And then we also have this monitor operation, which does kind of 2 functions. The monitor function checks that the transparency log is behaving correctly. And it also, if a user owns labels, the monitor operation will go through and check for any unexpected changes to labels that a user owns. And then sort of on top of that, we define this idea of non-interactive credentials, which is almost like a certificate where you can serialize some search operations that would normally be like request response, but you've serialized them so that you can send them to someone else, and whoever received it can verify some kind of binding between a label and a value without doing any network access themselves. And then in terms of how the transparency log actually operates, we have 3 deployment modes. The first one is contact monitoring, which is a single party deployment mode. So anyone can kind of set up a contact monitoring log on their own. The only consequence of that is that sometimes if a user looks up a label and the label was inserted very recently, the user has to remember to check back in with the log later and verify that that label was not, added 3 seconds before I looked it up and then deleted 3 seconds after I looked it up. So verifying that things stay in the log long enough that people can actually see that it happened. And then the other 2 modes are third-party auditing and third-party management, which both require you to have some kind of relationship with a trusted third party, but get rid of this use case where sometimes users need to maintain extra state. So with a third-party auditor, you have the service operator who runs the transparency log, and then the auditors kind of off to the side and just verify if the log is operating correctly. With third-party management, you have a manager who is basically running the entire transparency log, and then the service operator does some kind of lightweight things to keep this third party in check. And so those are all of the sort of binding guidance that we provide in the architecture document. We also provide just like advisory text on how to combine multiple logs, and that goes also into how to migrate from one log to another. We talk a lot about explaining in a kind of a user-friendly way the security and the privacy properties of the protocol. We talk about pruning the log for efficiency, so getting rid of kind of old things that you don't want to look at anymore versus pruning to comply with privacy law, where that's going to be a little bit more aggressive because you have to get rid of the data everywhere right now, versus with pruning for efficiency, you maybe can leave things around a little bit more. And then also we talk about how to actually structure an application's data in KT so that users, or not users, applications can convert the security properties of KT into broader security properties for their application. And all of that is really just to help people use KT successfully because it kind of is a complicated protocol. But yeah, that's it for the architecture document. Are there any questions on architecture? Hearing none, I am going to move on to changes to the protocol document. So the kind of exciting thing that we did in the protocol document is that we defined how third-party auditing works now. So the way that it works is every time the transparency log adds a new leaf to the log tree, it has to send this auditor update structure to the third-party auditor. And this auditor update structure contains the timestamp of the new leaf of the log tree. It also contains all of the prefix leaves that were added to the prefix tree with this new log entry, and then it also contains all of the prefix leaves that were removed from the prefix tree in this new version. And then it contains a lookup proof, which allows the auditor to, number one, compute the previous version of the prefix tree root hash, before the stuff was added and removed, and then allows the auditor to compute the new prefix tree root hash after all of the stuff has been added and removed. What the auditor does when it receives that is that, number one, it verifies that the timestamp is greater than or equal to the timestamp of the immediately previous log entry. And it also verifies that for all of the leaves of the prefix tree that were removed, all of those values had been in the log long enough that they were all published in at least one distinguished log entry before they got removed. And the purpose of that is to guarantee the kind of same security property we get with context monitoring, which is, data doesn't have to be in the log forever, but it has to be in the log long enough that someone looking for it would be able to find it easily. So that's how third-party auditing works. We also define how third-party management works. And this is a little bit simpler. So what happens with third-party management is that the service operator is kind of like a middleman between access to the third-party manager. So whenever users want to submit an update request, they take that update request and they submit it to the service operator first. The service operator does like access control and all of that. And then it wraps that update request in this manager update request structure, which just contains the user's original update request in it. And then it also contains a signature from the service operator. And so then whenever users actually do like a search result, the signature from the service operator that we provided here just gets immediately provided back, and users verify that whatever the third-party manager is giving them back as the value for this label was actually like authorized to be added to the transparency log by the service operator. So that's what that signature conveys. And then we also added a registry of cipher suites. This is probably the most exciting, although we'll dig a little bit into it. So the first cipher suite that we have defined here is a 128-bit security level cipher suite, where the hash function we use is SHA-256. And then for signatures, we use ECDSA P256. And for the VRF, we use the P256 VRF. And then the second cipher suite is sort of the same thing, SHA-256 for hash functions. And then we use EDDSA for signatures and the Edwards 25519 VRF for the VRF. And that's it. Just 2 cipher suites. It would have been nicer to have maybe like a 256-bit security level, or like potentially something that's post-quantum secure. But we're limited because the CFRG in RFC 9381 has only specified 2 elliptic curve VRFs, and they're both at the 128-bit security level. So that's just kind of all that we have to pull from the CFRG. So getting more cipher suites would likely require pushing a document through CFRG, and that is maybe out of scope for now in terms of workload. And then adding new entries to the registry for cipher suites. The policy there that we have set is specification required. And specification required, the rule there is that to register a new code point in the registry, you have to have a specification. That specification has to be public, and it also has to be permanent, so it can't change. And that's a lot of times in other working groups interpreted to be that you need an RFC to have a specification required code point, but that's not true. You can point to, I believe, other standards bodies, or like something on GitHub potentially, because the rules are just that it has to be permanent and public. Yeah, CFRG would be a lot of delay, I think. But we can register new code points afterwards if it's important. And then the protocol document from the top as well. So the protocol document defines 2 main tree structures that we work with. The first is called a log tree, and a log tree is what's called a left balanced binary tree, which is this property that every left subtree is the largest possible balanced binary tree. And then we also define a prefix tree, which is internally what's called a trie. And a trie is a tree structure with this property that every node represents some prefix, and then every node's left child represents that same prefix plus a 0-bit, and every node's right child represents that same prefix plus a 1-bit, and all of the search keys stored below a specific node all share its prefix. So those are the 2 kind of basic tree structures we define. Those are combined into what's called a combined tree. So at the top level, the combined tree is just a log tree, and then every leaf of the log tree contains, first of all, a timestamp of when the leaf was added, and then also the root hash of the current version of the prefix tree. And in the prefix tree, every time we change the prefix tree, what we're doing is we're inserting new label value mappings that we want stored in the transparency log. So over time, as we insert new values for labels, the prefix tree kind of grows like this, where at the very beginning, we're just going to have this base set of mapping label A to value B. And then over time, we'll add like C to D, and then it grows incrementally over time. And of course, you can look back in the log tree and see what the root hash of the prefix tree was at different points in time. So for working with this combined tree structure to make it like useful, we define 2 kind of sub-concepts. The first one is called the binary ladder. Binary ladder is just a series of lookups in a specific version of the prefix tree. And the purpose of these lookups is to determine whether or not a given version of a label exists or not. So I would do these lookups to determine if I'm looking for some specific version. I would do those lookups to determine if that version existed yet or not as a whatever version of the prefix tree. And then we also have this idea of distinguished log entries. So distinguished log entries are specific log entries, leaf of the log tree, that are chosen at a time-based interval. So new leaves of the log tree can be added kind of at whatever rate you need to add them. But we will go through and pick according to an algorithm, roughly 1 log entry that was added per every time interval. So if the time interval is 1 day, we'll go through and pick a log entry, roughly 1 per day. And the purpose of that is to align consistency checks between users. So users can all have this 1 log entry per day that we can all check as correct. And then in terms of how search works, like I said, we support fixed version search and greatest version search. The way that fixed version search works is essentially it's just a binary search through all of the leaves of the log tree. And we're binary searching for the first leaf of the log tree, where the prefix tree contains the label version pair that we're looking for. And then the way that we decide at each log leaf whether or not we should go left or right in our binary search is we use a binary ladder. So we go to, say, the middle log entry, we use a binary ladder from the prefix tree in that log entry to decide whether the version we care about exists or not. And if it does, we go right. If it doesn't, we go left. And then also for greatest version search is a little bit simpler. The purpose of this is just to find the greatest version of a label that exists. So we start at the rightmost distinguished log entry, which is the most recent distinguished log entry that was created. And we find the greatest version of the label that exists in that distinguished log entry. So that's the greatest version of the label that exists as of the newest distinguished log entry. And then we kind of binary search to the right, not really binary searching for something specific, just moving to the rightmost log entry, repeating that kind of step, finding the greatest version of the label that exists in each of these different log entries. And the purpose of that is just to ensure that we intersect with if a new version of the label was inserted since the last distinguished log entry was created. This guarantees that we'll intersect with whatever the label owner is going to check for correctness as well. And then the way that monitoring works is whenever we have previously looked up some version of a label and it was to the right of the rightmost distinguished log entry, so that means it was inserted very recently, we just check whether any kind of fixed version or greatest version search for that same version of the label would still converge back to what we saw originally. So it's kind of the inverse of the search operation, which is we're saying that, okay, with the new log entries which have been added since the last time I monitored the log, have those new log entries been created correctly, such that if someone searches for the same version of the label that I saw previously, will they still go back to what I saw originally? And also if the user owns some labels, what the user does is they do this kind of depth first search for distinguished log entries, and they walk all of the distinguished log entries which have been created since the last time they monitored. And in each of those log entries, we find the greatest version of the label that exists, and we check that that's what we expect. So essentially, we're just checking that nothing has been inserted for our label that we are not aware of, that we didn't authorize. So yeah. And that's roughly how the protocol document works. So this is my last slide. So before Montreal, next IETF, the changes that I would like to have to the protocol document are, I would like to add an explicit update operation, because right now update is basically just search, but that doesn't really work with the automated updates idea that I talked about at the beginning, where users are not always initiating the update operation themselves. And then, other sort of random minor tweaks and bug fixes I still have in my mind from last IETF. We talked about adding a prefix to all of the structures that are signed just for like domain separation. And I'm also planning to do a fresh implementation because, like we talked about, some implementations are getting published right now, which is really exciting, but they're all of relatively old versions of the protocol, which is what it is, because we implemented the previous version of the protocol, and then we decided to change the protocol to address things that didn't work very well. And so now we have to go back and implement the protocol again, but I would like to do that in the next couple of months. But yeah, the protocol document and the architecture document, I both think are getting fairly stable in the sense that I don't have a lot of work that I want to do on them. So please, review it, and also please share your thoughts on the mailing list or here. Yeah, that's all I've got.
I was waiting to see if someone else was joining to give other folks a chance, but I'll just go first. So thanks, Brendan. Just wondering, like you said, if the implementation that you know of are a little bit behind in terms of or compared to the protocol document. Do you have a sense for whether the implementations would want to move on to the latest versions? Like, do you know of that, or do you know if it's just a question of implementation effort, or is there something, like fundamental that are in the changes that would prevent someone from adopting the changes, even if it's like bug fixes, because it's like doesn't match the deployment point or something like that.
I believe that's on the table. Yes. I obviously don't want to make promises, but yeah, I don't really see a problem with that.
I think Marie probably left. She said she had a conflict. Yep.
Oh, yes, she did. A little bit earlier, sorry.
Do we have more questions for Brendan?
Felix, go ahead.
Felix.
Yeah, hi, thanks, Brendan. When you presented the service operator update, where every for the third-party management of the log, where every update is signed, I was wondering whether we should also allow for other mechanisms to do to authenticate these requests. For example, mutual TLS authentication on the transport layer, and then you don't sign each update, but you have a secure channel. It seems like this falls a bit out of the scope of the core protocol model, so we might want to be a bit flexible there. What do you think?
I'm not totally sure how TLS would work, because the point of this is that the service operator signs it, it goes to the third-party manager, and then later that signature is proxied back from the third-party manager to users whenever they do search requests. So the purpose is to sort of get that through line of the service operator signed it when it was added, and then later when I'm looking it up, I can see that that signature is still there. So the service operator must have signed it in the past. We can potentially have it signed by a different party.
Yeah, okay. I got the security guarantees you want to establish from the signature differently. So what you say makes sense. I guess this then has to do with which collusion of parties you want to accept or not accept, right? If you treat the third party operator and the log owner, or like the third party management and the messaging application, for example, as one party, then I guess you could even drop signatures entirely.
Potentially, yeah.
Yeah, okay. Thanks.
Thank you.
Any other questions from Brendan? All right, I think we can move on. Thanks a lot, Brendan. Right, next up, we have Felix.
No clickers required.
Yeah, hi. This is more a presentation for the record because I didn't want to let this meeting pass without saying anything, so I only have a single slide. As has been shared by Mary, we've been working on a verification of the draft in a verified reference implementation. The repository is linked here again. I'm collaborating with Linnard R. Quint, who's also working at ETH Zurich, and with Corey Myers and Jonathan Hoyland. You may know some of these names, they're also in chat. Sorry for not mentioning that on the slide. I unfortunately have nothing definitive to announce. We are progressing in both the implementation and verification, but unfortunately the progress is slower than hoped, and the reason is a mixture of verifying the identified properties is more challenging than we thought, and the team members have conflicting projects and cannot put in as much time as we had hoped. So now you can be the judge of how much percentage you assign to each of these reasons. But yeah, it falls in between of the two. Nevertheless, I think that the verification efforts we have put in so far have provided value. We didn't find any security issues in the draft so far, but many small quirks that you find while implementing the draft. And I think, yeah, Brendan and I were always very quick to address them. So I think all of them should be addressed in the current draft. Maybe there are some minor ones left open. And we intend to proceed as planned. I'm trying to figure out how to allocate the necessary resources to this project. And that's all I have to say on this point. Are there any questions? Good. Yeah, I'll be around still. That was my update on the key transparency verification. Thank you.
Cool. Thanks, Felix. We don't have much else. Do folks have questions, comments? Any last-minute presentations? Prachi, any thoughts?
No, I think we are on the right track. I have a question for Brendan, though. Brendan, you mentioned the updates you want to make before the next IETF. And those are just protocol document updates. Are you planning to make any to the architecture document as well?
I do plan to add some more, just basically non-binding sort of advisory text to the architecture document. So one thing that I want to talk about is with contact monitoring, there's a requirement that users maintain state. I want to kind of quantify how important maintaining state is, given that a lot of applications, people reboot their phone constantly, or like reset their phone or whatever. I want to see if I can quantify the security impacts of that.
Okay, thanks, Brendan. Sounds good.
Yeah.
So
All right.
I think we are getting to a point where after next IETF, we'll be closer to a last call probably. But we'll see. Yeah.
Deb, anything from you? Sorry, Deb, can you hear us?
Oh, yes, I'm sorry.
Was just asking you if there's anything from you.
Can you say one more time?
Anything from your side?
No.
Or should we close out the meeting?
No. Although I do think you can, if Brendan's not getting, is Brendan getting reviews of both of these drafts? Or is he just doing all this work by himself, or are other people reviewing, or how does this work? Because we need to start getting people to review it if that's not happening.
Oh, Brendan, do you have a request for review, or if you feel like there are things that the working group should be looking at more?
Yeah, I would definitely love more review on the document because, like I said, it's getting pretty stable, and there was a long time where the document was changing pretty dramatically, but now a lot of that has settled, and it would be really nice to get people to look at it fresh. Because if I don't get a lot of feedback, I think that we should do last call and just call it a day.
I guess it would be really helpful, like I mentioned a few times, to get folks deploying it to talk to you, and maybe that's already happening in the background, but getting that kind of feedback would be really useful.
Yeah, and that's definitely what my plan for the next couple of months is, to get a fresh implementation of it.
Cool,
Right.
thanks.
So if you're sitting here and you need something to do, you should review these drafts. Because you're going to get working group last call soon, and it'll be quicker if you've already looked at it.
All right. Thank you all for coming to KeyTrans. Thanks to Martin for being our note taker, and to all the presenters. Thanks, Deb, once again, and see you all next time and online.
Great. Hope to see you in real life in Montreal.
All
Thank you.
right, thank you.